Alright, this is Mr. Jones, and welcome to our first episode of Mr. Jones's class's video learning series. So today we're going to be talking about representing multiplication expressions. And what that means is we're going to be taking multiplication equations and we're going to represent them using different visuals and symbols to make our understanding a little bit more clear. So to begin, we have something called arrays. And arrays are basically rows and columns of little symbols. So in this case we have circles, and the equation is the number of columns multiplied by the number of rows, and if we add up all these circles we get 20, which is the answer to that multiplication expression. The next strategy we can use is called grouping. So this is a very simple strategy. Basically, you can take this multiplication symbol and replace it with the phrase groups of. So in this case, we have 9 groups of 3 stars. And the answer to that expression is obviously 18. The area model relates really strongly to our current study in measurement. So similar to arrays, you have again columns and rows, and when you multiply those together, you get 28 centimeters squared. However, unlike the array model, we have 1 centimeter squared boxes here, and if we count all those up, then we get the area in here, which again is that 28 centimeters squared. Last off, we have my favorite, the area box model, or what I'm calling the area box model. So for this method, we have to break up the factors. We have to decompose them into smaller, more manageable numbers. So in this case, we've taken the tens column, which is a 1, and we've made it what it really is, a 10. The 2 remains a 2. Same thing here. The 1 in the tens column becomes what it really is, a 10, and then the 5 stays a 5. And we've taken each of those decomposed factors and multiplied it by the other 2 decomposed factors. So in this case, we've got 10 times 10, which is 100. We've got 10 times 5, which is 50. We've got 2 times 10, which is 20, and 2 times 5, which is 10. And when you add all that together, you get 180. The reason that I really like this method or this strategy is visually you can really see the area of each of these decomposed factors when they're multiplied together. So unlike the box method that we originally learned that looked sort of more like a plain window, in this case, because we've got 10 by 10 here, the area of this would actually be 100 centimeters. And because we have 2 by 10 here, the area of that is actually 20. So it gives a very accurate representation of what the area truly is. Alright, so that's it for this episode of Mr. Jones's class video learning series. Thank you very much for watching, and stay tuned because there will be more content uploaded very soon. Thanks.